So what we just said, this is inverse trig functions video number 2. So what we just said was that the angle that has a sine equal to the square root of 3 over 2 is pi over 3. Awesome. So we just discussed notation. We also discussed how do we tell if the function is, how do we tell if the inverse is a function, and where we can go shopping. So in order to summarize where we go shopping, for the inverse sine function, or the arcsine of x function, which is the exact same thing, the sine of theta is equal to x, and we can go shopping for the inverse in quadrants 1 and 4, or negative pi over 2 to pi over 2. For the inverse cosine, or the arc cosine function, so for the inverse, we're going to go shopping from 0 to pi for the inverse, 0 to pi. And for the tangent function, again, we're going to go shopping from negative pi over 2 to pi over 2, which is the first and the fourth quadrants. Great. So the second sample problem, it says find the tangent of the arc cosine of negative 1/2. So what you can do is, what we're going to do, and always whenever we have a composition of functions, what you want to do is you want to start on the inside and then work your way outwards. So the first thing that we're trying to find is the arc cosine of a negative 1/2. So the arc cosine of a negative 1/2, it's asking the question, and this is what I highly recommend that you do, is that you ask yourself that question every single time. You ask yourself, okay, well, if I'm looking for the arc cosine of a negative 1/2, the question I have to ask myself is, what angle has the cosine equal to negative square root of 3 over 2 only at the stores that I'm going to go shopping in? So for cosine, what stores can I go shopping in? 0 to pi, so only store number 1 and store number 2, or quadrant number 1 and quadrant number 2. So let me go check out my shopping gear. I can only go shopping in quadrant number 1 and quadrant number 2 for the cosine, arc cosine function, or the inverse cosine. Well, in these two quadrants, where is the cosine going to be negative? Well, we know that cosine is negative in quadrant number 2. Cosine is negative in quadrant number 2 out of our two stores. So we know that we're going to go shopping in quadrant number 2. So do we know an angle, or 36, or do we know a triangle where we can use to answer the question, what angle has a cosine equal to a negative 1/2? Yes, we do. 30, 60, 90 triangle. You know that you can draw that in your second quadrant. Well, what angle can we place in this triangle to where our cosine would be equal to negative 1/2? Well, that angle would have to be 60 degrees. So we know that in order to answer this question, we're looking for the angle that has a cosine. So an angle that has a cosine equal to negative 1/2. So an angle that has a cosine equal to negative 1/2, I can't say that's 60 degrees because 60 degrees is in the first quadrant. So I have to find my angle all the way from my point of reference, which is my line right here, go and find the angle to my triangle, the hypotenuse of my triangle. So what angle is this? This angle would be 180 minus 60 degrees, which would give me 120 degrees. 120 degrees, I like degrees, but I love radians, so I'm going to convert that to radians. So the arc cosine of negative 1/2 is 120 degrees. 120 degrees is the same thing. In order to convert from degrees to radians, we know that we multiply by pi divided by 180. So that leaves you with 120 pi divided by 180, or 2 pi divided by 3 when you simplify. Wow, we just finished half the problem. So now, do we know how to solve for the tangent of 2 pi over 3? Heck yeah, we do. So now let's do that. So in order to solve for the tangent of 2 pi over 3, all we're going to do is we're going to say the tangent of 2 pi over 3 is equal to the sine of 2 pi over 3 divided by the cosine of 2 pi over 3. Do I know how to find the sine of 2 pi over 3? Yes. Do I know how to find the cosine of 2 pi over 3? Yes. I plug in my answers and I simplify my math. Keep it, change it, flip it. That is all we're doing whenever we get to problems that are compositions of functions. So that was a good sample problem. Now what I want you to do is I want you to take however long you're going to need to work through the next 5 problems. There are 5 problems on where it says your turn to drive on the back of your worksheet. The next video is going to have a couple of the solutions, so some of the answers to those problems. Just to comment on some of the more challenging problems, you actually don't need any of the angle measurements. So I did not give you any of the angle measurements, but what you can use are, your special right triangles, Pythagorean theorem, and you're not going to need any angle measurements. All you have to do is you have to just draw out your triangles and the answer will become clear. So tune in to the next video so you can have some of the answers to the inverse trig functions so you can check some of your work. Alright, peace.